Hello everyone, my name is Jeik Yoon.
And my name is Rubbo. Today we will be talking about the chemical reactions of copper.
We started with solid copper and placed it through 5 reactions.
After the last reaction, we were left with about the same amount of solid copper that we started with.
Fun stuff. I say fun on the premise that you all decided to give up your lives and take Chem 2 AP instead. Now please indulge on your very nutritious diet comprised of Jolly Ranchers and enjoy.
Before we can go on, we must address some serious safety hazards in this lab.
And be warned, 6 molar hydrochloric acid, nitric acid, sulfuric acid, and 3 molar sodium hydroxide base can and will burn your face.
I can feel my face when I'm with you.
And for that reason, students must use goggles and aprons at all times.
There's a gas too.
That's right, the first reaction produces nitrogen dioxide. This is a lethal gas, so students must complete this reaction underneath the fume hood. Students will be using the fume hood for other steps as well.
Because we do not have an apron built for scientific use, we will be using kitchen aprons instead, strictly for demonstration purposes.
Let's do this.
Just do it!
We placed 0.4998 grams of copper turnings into a 250 milliliter beaker. We then poured 5 milliliters of concentrated nitric acid into the beaker under the fume hood and observed the reaction.
As you can see, the solid copper dissolved and a red nitrogen dioxide gas was released. Let's look at what really happened in this reaction.
In this redox reaction, solid copper reacted with nitric acid to produce copper nitrate, nitrogen dioxide, and water.
After this, we added 100 milliliters of distilled water. We then added 30 milliliters of 3 molar sodium hydroxide.
This is a double replacement precipitate reaction. Copper and hydroxide formed a precipitate, and sodium and nitrate were spectator ions.
We heated the solution, which caused copper hydroxide to decompose into copper oxide and water vapor. After allowing the copper oxide to cool, we decanted the supernatant liquid. We then added 200 milliliters of hot distilled water and repeated the decantation process.
Adding 15 milliliters of sulfuric acid made the solution blue again.
When we take out all the non-reacting ions in this double replacement acid-base reaction, we can see that solid copper oxide reacted with hydrogen ions to form water and aqueous copper 2 ions.
We then slowly added 2 grams of zinc into the beaker under the fume hood until gas was no longer produced.
In this single replacement reaction, zinc took the place of copper to form aqueous zinc sulfate and solid copper.
We added 20 milliliters of 6 molar hydrochloric acid to the beaker under the fume hood in order to remove all of the zinc. We then added 50 milliliters of distilled water to the beaker. Afterwards, we decanted the supernatant liquid and transferred all of the solid copper into an evaporating dish that we had previously weighed.
3 10-milliliter portions of water were added to the evaporating dish and decanted. 5 milliliters of acetone was then added and decanted.
After drying the solid copper on a hot plate, our recovered mass was calculated to be 0.4594 grams, a 91.92% recovery.
You're probably wondering where all the lost copper went. We can explain that.
Many steps in this procedure require students to decant the supernatant liquid from the solid. Without the use of a filter, small particles of a precipitate cannot be separated from the filtrate. This is an imprecise technique.
Solids can also be lost when transferring precipitates from one beaker to another. Even after washing glassware, some of the solid is left behind. Copper stayed on the beaker when it was transferred into the evaporating dish.
Now on the presumption that you all need to replenish on your source of apple, grape, and watermelon Jolly Ranchers, nodder, we leave you with that and hope you all learned something new.